Good morning, friends. Today, we'll discuss one topic, that is in a geometrical figure. Okay, one geometrical figure, that is four-sided geometrical figure, which all sides are equal. Okay, what is that name? Yes, that name is square. Of side, yes. Then area of square formula. Very good. S into S. This is nothing but area is equal to side into side square. Right? Suppose if side is 3 units, then area is equal to how much? 3 square. 3 square means 3 into 3. Value is 9. Suppose side is 4 units. So A is equal to 4 square. 4 into 4, 16. Suppose the side is 5 units. 5 square. 5 into 5, 25. If side is 2 units, 2 into 2, 4. If side is 1 unit, 1 into 1, 1. Therefore, what numbers we got? 1, 4, 9, 16, 25, so on. They are all areas of squares. If side is 1, 1 unit. If side is 2, 4 square units. Side is 3, 9 square units. Automatically, the numbers what we got is 1, 4, 9, 16, 25, so on. What type of the numbers these are all? Square of natural numbers, right? 1 square, 2 square, 3 square, 4 square, 5 square, so on. Square of natural numbers. What are these? Square of natural numbers. Then this type of numbers are called perfect squares. What are these? Perfect squares. Okay. So today our chapter name is that only. Squares and, okay, I'll tell you later. Now these are all perfect squares. What is meant by perfect square? If a number is multiplied by itself, if a number is there, x, multiplied by itself, then x square is perfect square of x. Simply, if 9 is there, multiplied by 9, 9 square, 9 9s are 81. 81 is a perfect square of 9. Suppose 11 into 11, 121. 121 is a perfect square of 11. Suppose 144 is a perfect square of 12 because 12 square is 144. Suppose 324 is a perfect square of 18. Okay. So what is meant by perfect square? If a number is multiplied by itself, then the resultant is called a perfect square. Okay? If a number is multiplied by itself, then it is called a perfect square. Okay, now we'll count how many perfect squares are there. Can we count? Suppose 1 square, 1, 2 square, 4, 3 square, 9, 4 square, 16, 5 square, 25, 6 square, 36, so on. These are all 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, so on. These are all squares of natural numbers. N is what? N belongs to a natural number. Or simply we can call it as counting numbers. What they are? n is called natural numbers or counting numbers. So how many will be there? Okay, undoubtedly infinite numbers are there. Right. Now my question is, okay, find the perfect squares or perfect square numbers between 30 to 60. Find the perfect square numbers between 30 to 60. How many are there? You need not check 31 square, 31 is a perfect square, no, 32, no, 33, no. You need not count like this. Then what shall we do? What is given? 30 to 60. What is nearer a perfect square to the 25? Okay, sorry, to the 30. The nearest to perfect square 30 is, see here, 30 is lies between 25 and 36. Is it? 30 is lies between 25 and 36. So 25 after what number will come? As usual here 30. So 36 is a perfect square. 36 is a perfect square. 36. Next 60. Okay. Now and keep on going. 7 square. 8 square. 8 square is how much? 64. Okay. So below number is what? 49. That is 7 square. So in between 30 and 64, there are only 2 perfect squares are there. Okay, there are only 2 perfect squares are there. Now, okay sir, this is a 30 and 60 only. Very easily you found out. Good. Whatever it may be, from 300 to 600. In between 300 to 600. How many perfect squares will be there? Okay, 30 to 60 means 30, that is nearest perfect square is lies between 25 and 36 only. So 30 I was taken. Here, after that 60 is 64, 8 square is 64, in between 30 and 64, 36 and 49. Because here it is 25 is 5 square, 64 is 8 square. See, counting numbers came 5, 6, 7, 8. In between 5 square and 8 square, there are only 2 numbers will exist. That is 6 square and 7 square only. We cannot exist more than that. What are those? Natural numbers. Now, 300 to 600. How many perfect squares are there is the question. So, how to find out the 300 to 600? Okay? Okay. Now, the basic idea is 10 square is how much? 100. 20 square. Okay? 20 square. 2 square is how much? 400. Because 1 0 is square, 2 zeros will come. Okay? 20 square is 400. So, our number is 300. After 300, your 400 is coming. After 300, 400 is coming. Alright? So, here one technique I will tell you. One shortcut. Okay? One shortcut, that is 15 into 15. 15 15s are. What is that? 15 15s are. You need not multiply. Okay? See the one, draw one line like this. 5 5s are 25. Add 1 to this number, before number, then it becomes 2. 1 2s are 2. 225. If you want to check 25 into 25, 5 5s are 25. Add 1 to the before number, then it is 3. 3 2s are 625. 35 into 35. 5 5s are 25. Add 1 to the previous number, then it is becomes 4. 4 3s are 12. 35 into 35 is 1225. Suppose 65 into 65. 5 5s are 25. Add 1 to the before number, that is 7. 7 6 are 42. This is possible only when both are endings with 5. Okay? It is not possible with the 16, 16, 17, 17 or 32 into 32. It is possible only with 25 to 25, 35 to 35 or 65 to 65. Okay, this type of techniques we will learn in this class many more. Not only one. Okay, now okay, once again the same technique. What is that? 15 into 15 is equal to, once again I am telling, 5 5s are 25. Add 1 to the number 2. 1 2s are 2. 225. Now we need the numbers between 300 to 600. In between 300 to 600. So here 15 square is how much? 225. But 20 square is how much? 400. After 15 square, what number will come? 16 square, 256. 17 square, 289. 18 square, 324. So 324 is a perfect square, that is 18 square. Now come to 600. 30 30s are how much? 30 square is how much? 900. So definitely after 600 only 900 will be there. That is 30 square. Now we are setting numbers, the perfect squares, 300 to 600. Of course 300, that is 18 square. Here it is 30 square. Between 18 to 30 only. And very close to that here. Before 30, I am checking this rule once again. 25 into 25. 5 5s are 25. Add 1 to this number, then it is 625. So 25 square is 625. So definitely it will be now 24 square. So 18, 19, 20, 21, 22, 23 and 24 square. Okay. So 1, 2, 3, 4, 5, 6, 7. There are 7 perfect squares will be lies between the two perfect, okay, any two numbers. This is the way to find out how many perfect square numbers are there in between any two numbers. So what you should do? The nearest perfect square number to this and nearest perfect square number to that you should find out. For that, this is the basic principle for the, okay, with zeros, 10 square 100, 20 square 400, 30 square 900. If it is close, then in between 10 and 20, 15 will come. 20 and 30, 25 will come. With the 5, you know how to do the multiplication now. By using this process, you can find out any number of perfect squares lies between any two numbers. Okay? Okay. Now, we'll discuss some properties of perfect squares. Okay? Properties of perfect squares. First property. So, before going to start the property, I'll give some questions here. Okay, 6238 is a perfect square. Which number will be? Or else 75285, 64187, 1002053, 76284. Okay, 10596, or else 23578. Okay, 13573, or else 15222. Among these numbers, which is a perfect square and which is not a perfect square? Okay, there is a property to identify what is not a perfect square. How? A number which is not a perfect square, we can identify very easily. Okay, if not, okay, some out of these numbers, this is not a perfect square, like this is not a perfect square, this is not a perfect square, only this is only the perfect square you think of. Okay, then how to find out its square root? That is our second concept. So first we are identifying what is not a perfect square strictly. Okay, we know that properly. That is, we can identify surely and strongly what number is not a perfect square. Okay, by this process. That is, okay, any number, one digit number or two digit number or three digit number or 10 digit number, whatever it may be, any number will ends with the digits, all these numbers only. 6, 7, 8, 9. By using these 10 magic digits only we can form, or you can create, or you can write any number. Suppose, see, I am telling about the units digit. What is that? Units digit. Okay, whatever the number you write, units digit should be like this only. Okay, units digit will be like this only. Now, okay, one thing I will write here, you just see 1 square, 1 only. Suppose 11 square, 121. 2 square, 4. 12 square, 144. 3 square, 9. 13 square, 169. 4 square, 16. 14 square, okay, 196. 5 square, 25. 15 square, 225. 6 square, 36. 16 square, 256. 7 square, 49. 17 square, 289. 8 square, 64. 18 square, 324. 9 square, 81. 19 square, 361. Of course, 10 square, I am writing here 100. Or else 0 square will become 0. 10 square will be 100. Now, just imagine or observe, what are the units places? Only the units places. 1, 4, 9, 6, 5, 6, 9, 4, 1. Why I ask you to observe this? What is coming? What it came? Okay, I am writing these numbers little above this line. Once again. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can write any of the numbers, infinite numbers, by using these digits only. And in that, your units place, units digit will be out of these 10 digits, any one digit will be. Now, what it came? Just strike it off. 0 came, 1 came, 4 came, 9 came, 5 came, 6 came, any other number came, just observe. Anywhere, 2, 3, 7, 8, it came. No. Good. So, 2, 3, 7, 8 are there in units place. What is this? 2, 3, 7, 8. These 4 numbers are there in the units place. It is never a perfect square. We can write. That is the property 1. If any number is consisting of the numbers 2, 3, 7, 8, they never be a perfect square. See here, 2. It is not a perfect square. 8. Not a perfect square. 7. Not a perfect square. 3. Not a perfect square. 8. Not a perfect square. 3. Not a perfect square. Without thinking or what number it will come, nothing, no need. So if units place is 2, 3, 7, 8 are there, yes, it is not a perfect square. We can say very strongly. Okay, but we cannot say, suppose this number is there, 7, 6, 2, 8, 4. Is it a perfect square? May or may not. There is a procedure to find out whether it is a perfect square or not. Suppose here it is 6 is there. Is it a perfect square? Okay, we don't know. Whether it is a perfect square or not, we don't know. There is a procedure to find out whether it is a perfect square or not. So, but we are categorizing. Okay, suppose a bunch of numbers are given to you. Okay, some numbers are given to you on the papers. Okay, what are perfect squares, what are not perfect squares? We are categorizing that what are not a perfect square, we are throwing into out. How? By using the units place. If units digit is 2, 3, 7, 8 is there, observe. If these 4 numbers are there, any one number is there, yes, it is not a perfect square, you can take it away. If the remaining numbers are there, yes, may or may not be a perfect square. Okay, suppose if 5 is there, okay, 5, suppose 25 is a perfect square. Is 15 is a perfect square? No. So, here 35 is a perfect square? No. Okay, like that, it may be a perfect square, may not be a perfect square. So, we'll discuss this one in the next concept. Okay. Now, next property. Square of even number is even. Suppose 4 is a even number. 4 square. 16. 16 also even number. Suppose 16 is a even number. 256. 256 is a even number. 14 is a even number. 196. So square of even number is even number. Similarly, the next property. Square of odd number is. Square of odd number is. Good. Odd only. Because 5 square, 25 will come. 9 square, 81 will come. Okay. And the next, some 7 square, 49 will come. 9. So square of even number is even. Square of odd number is odd. Okay. We'll go to the next property now. Okay. Now, suppose